Today we'll discuss about Ethernet. Ethernet is basically a LAN standard, and IEEE 802.3 Ethernet standard is used for LAN or MAN. So LAN differs. There are different standards of Ethernets. These standards are standard Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. Basically, LAN differs only in MAC substandards and physical layers. So this is the frame format for traditional Ethernet or standard Ethernet, where the speed is 10 Mbps. At the MAC sublayer, we know MAC is a sublayer of data link layer, and data link layer is divided into two sublayers, MAC and LLC. MAC is the media access control sublayer, and LLC is the logical link control sublayer. So in MAC sublayer, it deals with access control and framing, and the access method is one persistent CSMA CD. We have already discussed in our CSMA portion that there are three types of persistent methods: one persistent, non-persistent, and zero persistent. So it is the one persistent method. Now we are directly coming to the frame structure. First is the preamble. Preamble start frame delimiter. SFD is the start frame delimiter. Preamble consists of 7 bytes. It contains it contains alternating 1 and zeros. Basically, preamble is attached in physical layer. It is not a part of the data link layer. And when we go through the whenever the receiver receives this frame and goes through the preamble sections, actually preambles does not contain any significant data. Preamble actually gives us the time to synchronize between the sender and the receiver. So while receiver gets this part of data, receiver does not has to interpret whatever the data written in this preamble section because it is alternative 1 and zeros, and it is an insignificant data. So at this moment of time, receiver don't have to interpret the data sent by the sender. Rather, the receiver synchronizes with the sender at this time. Then start frame delimiter. It is a 1 byte data, and the structure of this 1 byte or 8 bits, 10101010, and finally 11. So this 1010 is continuing from the previous preamble, and when we get 11, you can see last 2 bits are 11. That means this is your last chance for synchronization, and after that whatever you are getting, that is the actual data you have to interpret. So these two portions are basically added in the physical layer, and now from this destination address field, the data link layer portion starts. Because Ethernet is a data link layer portion, and data link layer handles MAC addressing or physical addressing. So this destination address and source address is basically the MAC address, which is of 6 bytes. Next field is the length field. PDU is the protocol data unit. So next field is length field, where number of bytes in data field are written. You can see next field is the data field. So the amount of data, the size of the data is specified in this length field. Now you can see this is the example of an hexadecimal address, physical address, which is basically written in hexadecimal. LSB of the first byte, that means LSB is the least significant bit. So from here we will get the LSB. If the LSB of the first byte is 0, that means it is an unicast address. If the LSB of the first byte is 1, we have to convert this data, this byte, into the corresponding binary. And now after that, if we get the LSB of the first byte is 0, then it is an unicast address. If LSB of the first byte is 1, then it is multicast address. And if it is all ones, that means FF in this way, we know it is a hexadecimal system, and if means all ones, then it is a broadcast address. Now in the physical layer, the encoding standard that is used for data transmission is the Manchester encoding. We'll discuss about the Manchester encoding and differential Manchester encoding, etc. in our physical layer portion. Now these are the some standard cables used in this Ethernet standard Ethernet. First is 10 base T. If we go to the start portion, we can see 10 means this traditional Ethernet or standard Ethernet deals in 10 Mbps speed. So from this 10, it is coming here. Base means baseband. There are two types of channels: baseband and broadband. So base means broad baseband, and 5 means 500 meters. That is the distance allowed in this type of cable is 500-meter. And after that, if we want to extend our network, we have to use repeater. Then 10 base 2, 2 means 200 meters. It's actually not exactly 200 meters, it's just near about 200 meters. Mm, then 10 base T, this T means twisted pair cable, and this F means fiber optic cable. So here are the some examples of the cables that is used in standard Ethernet or traditional Ethernet. After that, there are fast Ethernet, which deals in 100 Mbps speed, and then there are gigabit Ethernet, which is having a speed of 1000 Mbps, and then 10 gigabit Ethernet, which deals with 10,000 Mbps speed. So that's all for the Ethernet, which is a protocol used in data link layer.